Welcome back, everybody. We're going to work on the rest of Chapter 6 today on solving exponential equations. So let's start with what is an exponential equation. This is not part of your notes, but you want to jot this part down. If we had x plus 5 is equal to 7, then this is called just a linear equation. If I have 3 to the x power is equal to 9, this is an exponential equation. And it's exponential because our variable is up where an exponent would be. And what it's asking you is 3 to what power would be 9? And we know that that would be 2. 3 squared is 9, or 3 to the second power is 9. And so in this case, if I'm looking at this equation, x is equal to 2. Another way that we could look at that is, let's say that we had 4 to the x power is equal to 16. And let's pretend that we don't know that 4 squared is 16. So instead, I would want to find same basis. Can I make 16 into 4 to some exponent? 16 is 4 squared. And so now if I look at this, I have 4 to the x power is equal to 4 squared. Because they are both base 4, then we can say x is equal to 2. And we've solved for x that way. Based on this, for the first part of our notes, as long as our bases are the same, then we can kind of ignore them. They don't go away. We're just ignoring them and solving for the variable in the exponent. So if I look at this first set of examples, and I have a there, we have a base 3 and a base 3. Because they are both base 3, we can say the exponents, which are x plus 1, and on the right side, 5, we can say x plus 1 has to equal 5, because they're both a base 3. If I solve this for x, we would subtract 1 from both sides. We get x is equal to 4. So how do we know that that's right? And what does that mean? Well, if I plug that 4 into our equation, then it would be 3 to the 4 plus 1. 4 plus 1 is 5. So is 3 to the 5th equal to 3 to the 5th? Yes, because they're both base 3 and the exponents are both 5. So x is equal to 4. If I look at example B, remember, even though this first 6 does not technically have an exponent right now, it really does, because all exponents, if there's not one written, would be 1. And we have 6 to the 2x minus 3 power. These are both base 6. So because of that, we can say 1 is equal to 2x minus 3. Solve for x. Add 3. And then divide by 2. So we say x is equal to 2. But does that work? Well, we have 6 to the first power 2 times 2 minus 3. 2 times 2 is 4, and 4 minus 3 is 1. 6 to the first is equal to 6 to the first. That's true. So we know that x is equal to 2. Letter C. These are both base 10. So since they are both base 10, we can say 3x is equal to 2x plus 3. Let's get our like terms together. The opposite of a positive 2x is a negative 2x. 3x minus 2x is 1x. These add to 0, bring down the 3. We get x is equal to 3. We can double check that by plugging 3 in for the x on both sides. 3 times 3 is 9. 2 times 3 is 6. And then over here, 6 plus 3 is 9. 10 to the ninth is equal to 10 to the ninth, and that's true. So our x value is 3. Pause the video, take a couple of minutes, and try 1, 2, and 3 of the U-tries. This next set of examples, we no longer have like bases. 5 and 125 are not the same. Well, I want to make them same bases. I can't break 5 down any further. So we say, can I make 125 into 5 to some exponent? Well, let's try it. 125 divided by 5 is 25. 25 is 5 times 5. I have 3 5s. So 125 is the same as 5 to the third power. Now that I have same bases of 5 and 5, we can take our exponents. The exponents say that x is equal to 3. So we've solved this to know that x is equal to 3. That means if I were checking this answer, 5 to the third is 125. And if I put that into my calculator, 5 caret 3, we should get 125. Example B, 4 and 2 are my bases. You always have to go with the smaller one. So I want to say, okay, if I know that 2 is our smallest base, can I change 4 into 2 to some exponent? Well, 4 is 2 times 2, or 2 squared. Remember, there's an x there on the outside. Exponent rules say when I have two exponents next together, we multiply them. So 2 times x is 2x. Well, now our bases are the same. They're both base 2. So we can say 2x is equal to x minus 3. Bring our like terms together. The opposite of a positive x is a negative x. So we're subtracting x from both sides. 2x minus 1x is x. These add to 0. Don't forget to bring your negative with the 3. And so we get x is equal to negative 3. Let's take a look at this last one. I have 9 and 27. Again, they're not the same base. I look at my smaller number is 9. So can I change 27 into a base 9? Well, 9 to the first is 9. 9 squared is 81. So that's not going to work. What can I break 9 down into? Well, I know that 9 is 3 times 3, or 3 squared. So I change this 9 into 3 squared. We still have that x plus 2 on the outside. So then we're saying, okay, well, can I change 27 into something with 3? Well, 27 is 9 times 3, and 9 is 3 times 3, so there's 1, 2, 3 threes. So 27 is the same as 3 to the third, and 3 to the third goes where the 27 is. We still have the x. Remember, again, when exponents are next to each other, we're multiplying. So I'm multiplying 2 times x plus 2 and 3 times x. Distribute our 2 to the x plus 2. We get 2x plus 4 is equal to 3x. I'm going to move my like terms together. The opposite of a positive 2x is a negative 2x. Those add to 0, so we bring down the 4. 3x minus 2x is 1x. And so x is equal to 4. Remember, we can plug those in to our x values up there and make sure they work. So you would say that 9 to the 4 plus 2 is the same as 27 to the 4th. 4 plus 2 is 6. So they don't look the same right now. But if you go into your calculator and you do 9 to the 6th power, you get a super big number. It's 531,441. And then you do 27 to the 4th power, and you get 531,441. So even though the bases aren't the same in the original equation, when I plug in my x value and I evaluate those, you end up with the exact same value. So go ahead and try the try example of numbers 4 and 5. The last part of our notes today talks about what happens if I have fractions. Well, remember, I can change fractions by flipping them. So I want to go back, jot this down on the very bottom. If I have 3 to the negative first power, remember negative exponent rules, take our base, flip it around, and then we drop the negative on the exponent and make it a positive because the negative did its job. So knowing that about negative exponents, if I want this 1/2 to not be a fraction anymore, I want to flip that 2 back up. Right now, this is 2 to the positive first power. So if I flip it up, it's now 2 to the negative first power because we undid that negative exponent. Now that I've got no fraction, I have a base of 2 and a base of 4. Our smaller base is 2. Negative 1 times x is negative 1x. Can we rewrite 4? Well, we can. 4 is 2 times 2, or 2 squared. Now we have same bases. They're both a base 2. That means we can say the exponents have to be equal to each other. Remember, this is a -1 times x. The opposite of multiplying by -1 is dividing by -1. And 2 divided by -1 is -2. So our answer for x is equal to -2. Again, if we plop that into our calculator, 1/2 to the -2nd power, we get an answer of 4, which matches. Let's take a look at letter B. I have a base of 4 and a base of 1 over 64. My smaller base is 4, so we're going to try to leave that. Let's start with 1 over 64. In order to flip that back, so it's not a fraction anymore, remember that is 1 over 64 to the positive first power. To flip it back up, we have to make that 1 a negative. Then we say, well, can I make 64 into a base 4? Well, 64 divided by 4 is 16, and 16 is 4 times 4. So there's 1, 2, 3 fourths, or 4 to the third power. Exponents next to each other, the rule, remember, is to multiply. 3 times -1 is -3. Now we have same bases, they're both base 4. So we can say that x plus 1 is equal to -3. The opposite of adding 1 is subtracting 1. Those add to 0. -3 minus 1 more is -4. So our solution is x is equal to -4. We can double check that. 4 to the -4 plus 1 power. -4 plus 1 is -3. And if you plug that into the calculator and do math, enter, enter, then you get 1 over 64. This is where we're going to pause for today. Thanks so much for joining me. Have a great rest of your night.